If you are watching this video for the first time, make sure you are subscribing to Anantalakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everyone, welcome back to Anantalakshmi Academy. This is the second part of applications of trigonometry that we are going to discuss today, which includes exercise 12.1. So for now, even before this video, you must have gone through the introduction, and I strongly suggested to go through the examples. If you have already gone through the examples, then well and good, we are ready to get started. If you have not, I strongly suggest you to go through the examples first, even before you listen to this problem. That is going to give you a better view or an understanding of how are we going to look at the problems in the exercise. If you have already gone through, let's get started. Okay, this is the first problem in exercise 12.1. So this is the first problem. A tower stands vertically on the ground. First thing is, so in applications of trigonometry, it is very important for us to understand the question first and accordingly draw the diagram. All right, you get you get the problem or the solution very easily once you draw the diagram perfectly. So applications of trigonometry is something which deals with correct images or correct diagrams. If you look at this problem, a tower stands vertically on the ground. Vertically on the ground. Let me draw a vertical line. Alright. From a point which is 15 meters away from the foot of the tower. Where is the foot of the tower? Here is the foot of the tower. From a point which is 15 meters away. 15 meters away from the foot of the tower. From here, this one is 15 meters away. The angle of elevation of the top of the tower is, I already told you, angle of elevation is nothing but the angle made with taller objects. So, from the foot of the tower to the top of the tower, okay, is 45 degrees. What is the height of the tower? Okay, you know one side and you know the angle. Now it's our turn to name the triangle and draw the right angle. See, you know the adjacent side of the triangle and you know the angle. We know trigonometric ratios, sine or cos, tan, cosecant, secant and cot. Can't we figure out the height of the tower? Yes, we can. So let's get started. So in order to get the height of the tower, we need to identify a trigonometric ratio which is using this height of the tower. This height of the tower is nothing but opposite side with respect to the angle of elevation. Are we aware of any trigonometric ratio which uses an opposite side? Yes. What is it? Sine, cosecant and tan. Alright. So if we have to figure out this, can we use sine? Sine is nothing but opposite by hypotenuse. Oh, we do not know the hypotenuse part. So can we use tan? Tan is nothing but opposite by adjacent. Now we know the angle and we know the one of the side. Can we figure out this? Yes. So let's do that. Solution. So given in the solutions in applications of trigonometry will be very short. So I recommend you guys to write this given angle of elevation is equal to this. The distance from the tower is equal to 15 meters and all. Alright. So the angle of elevation equal to angle A is equal to 45 degrees. Distance from foot of the tower AB is equal to distance from foot of the tower is equal to, what is it? 15 meters. Alright. Now, so did you guys understand why am I taking only tan but not sine and cosecant? Because if I take sine or cosecant, we have both the sides not known to us. So if I take tan, one of the sides is known, the angle is known, hence we will be able to figure out the height. Height is nothing but BC. They are asking us to find BC is equal to question. So we know that tan 45 degrees is equal to what? Tan is opposite by adjacent, that is BC by AB. What is tan 45? According to the trigonometry table, it is nothing but 1. What is BC? The height of the tower, which we are here to figure out. What is AB? 15. Okay, from here, can we figure out what is BC? 15. 1 into 15 is nothing but 15. Hence, the height of the tower is 15. Okay, this is about the first problem. See how simple it is? You just need to understand, read the problem correctly, thoroughly, and then draw the diagram. Alright, this is about the first problem. Then jump into the second problem. So, for the second problem, let me read out the second problem for you. So, a tree breaks due to storm and broken part bends so that the top of the tree touches the ground by making 30 degrees angle with the ground. Alright, so he says a tree broke due to storm. So let me draw the tree first. This is nothing but a tree, even before breaking down, a long tree. Alright, what he said, a tree breaks due to storm and broken part bends. So let me assume this is the height of the tree which is broken. From this height it must have broken. Alright, and this part, so that the top of the tree, this guy is going to touch the ground by making 30 degrees angle with the ground. So this guy makes an angle of 30 degrees with the ground. Okay, this is what? This is the same height. This is the same height even before breaking. This guy now has come down. So this is broke and this has come here, touching the ground at an angle of 30 degrees. Now the distance between foot and top of the tree, the distance between foot of the tree and top of the tree. Top of the tree is not here because it broke and it is touching the ground. Understand it correctly. Earlier there was a tree of this height. Now it broke down such that it is touching the ground at an angle of 30 degrees. Now he says that here is where students almost commit mistake. The distance between foot of the tree and top of the tree, they assume this, not that. Since it broke and is touching the ground, the distance between foot and top is touching here. This distance is given as 6 meters. Find the height of the tree before falling down. If it hasn't fallen down, this line is going to stand on this line. That is the original height of the tree. So, in order to know the height of the tree, I need to know this and this. If I stand up this hypotenuse on the opposite side, that is what the height of the tree before breaking down. Isn't it? Just because it broke, this line has come here. This is what this needs to be standing on here. So, if I name this triangle, what is the height of the tree before breaking down? AC plus BC, isn't it? Because it bent, it broke and it bent. If this is going to stand on this, that is the actual height of the tree. So let us solve to get AC plus BC. Okay, that is the height of the tree before falling down. After falling down, BC is the only height of the tree that is standing. But what has fallen on the ground, that is AC. Alright, so let's get started. Solution given. What is this? Angle of elevation or depression? This is looking at something which is taller than this. So this is angle of elevation. Angle A is 30 degrees. Now the distance between foot and top of the tree. Distance between foot and top of the tree is equal to AB is equal to 6 meters. So we need to find this guy and this guy. If we are going to add AC and BC, that is what the solution is going to be. So let's quickly find BC first. How do we find BC? We know the adjacent side, we know the angle of elevation. Can we find BC? Yes. So tan 30 is equal to BC by AB. Tan 30, what is tan 30? 1 by root 3. What is BC? That is we need to figure out. What is AB? 6. So BC is nothing but 6 by root 3. This is what the height of the tree remaining after it broke. So what do we need to figure out? We need to also figure out AC. So one thing is you can do with the Pythagoras theorem. If not, since we are dealing with trigonometry, let me just do it with sine. Sine, that is nothing but opposite by hypotenuse. So sine 30 is equal to BC by AC. What is sine 30? Value of sine 30 is 1 by 2 from the table. BC is 6 by root 3 and here comes AC. So if I take this AC this side, AC is equal to 6 into 2 by root 3. What is 6 into 2? 12 root 3. Sorry, 12 by root 3. If we are to simplify this, we can write it in the form of 4 multiplied with root 3 into root 3. That is nothing but root 3 into root 3 is 3. 3 multiplied with 4 is going to give you 12 by root 3. Root 3 gets cancelled. AC is equal to 4 root 3. What is this? AC is equal to 4 root 3. What did they ask us? Find the height of the tree before falling down. What is the height of the tree before falling down? Height of the tree before falling is nothing but BC plus AC. What is BC? 6 by root 3. What is AC? 4 root 3. If you take the LCM, this is going to be 6 plus 4 root 3 into root 3 by root 3. 6 plus 4 3s are 12. 12 plus 6 is 18 by root 3. 18 by root 3 again can be simplified into 6 into root 3 into root 3 by root 3. And we got the answer as 6 root 3. Okay. So they gave the example like this. A tree is broke down from here with of height this much to it broke down to such that it touches and making an angle of 30 degrees. So what have we done? We just drew a line, the line of sight line and the angle of elevation. And then they asked us to figure out the height of the tree before falling down. If they just asked us the height of the tree, this is going to be sufficient before falling down. So it has to be BC plus AC, and that's 6 root 3. So that is about problem number 2. Let's jump into the problem number 3. Yeah, here we are with the third problem. It is given in the third problem that a contractor wants to set up a slide. This is the first example, live example which we took for understanding trigonometry. Okay, contractor is setting up the slide for children in the park. So he wants to set it up at the height of 2 meters. So how will the slide be? We already noted down as an important point that all the objects are assumed to be linear. So even though the slide looks this way, we are going to consider it as a straight line. So how will a slide be? This is going to be a slide. So at the height of 2 meters. So he wants to set it up at a height of 2 meters, making an angle of 30 degrees with the ground. So this guy, the slide is going to make an angle of 30 degrees with the ground. What should be the length of the slide? What is the length of the slide? Nothing but the hypotenuse. Okay, let us name the triangle quickly. A, B, C and the right angle. Okay, he is trying to set it up at the height of height should be the height of height from the ground for the slide is going to be 2 meters. So and it is making an angle of 30 degrees with the ground. Any angle which is looking at a taller object is known as angle of elevation. So let's jump into the solution part. Given height from the ground is equal to BC is equal to 2 meters and angle of elevation is equal to angle A is equal to 30 degrees. They are asking us to figure out what should be the length of the slide. Nothing but AC. AC is equal to question mark. So now you know BC, the opposite side, and you want to figure out the hypotenuse. So we have are we aware of any trigonometric ratio which deals with the opposite and hypotenuse? Sin theta, right? Sin theta is equal to BC by AC. Sin theta is nothing but sin 30 degrees is equal to 2 by AC. So sin 30 is 1 by 2 into 2 AC. So if you cross multiply, AC becomes 2 multiplied with 2, 4. So what should be the length of the slide? 4 meters. Alright, that's about problem number 3. So let's jump into the problem number 4. Siva. So here we are with the 4th problem. Let me read out that for you. Length of the shadow of a 15-meter height pole is 15 root 3. Okay, here we are dealing with a shadow. So you don't know where the shadow is. Sometime in the morning it is aligned to the right and sometimes it is aligned to the left. So how do we figure that out? For that, at 7 o'clock in the morning, so morning. So if you consider this as the sun and here is a boy, it will be like this. The shadows in the morning goes bigger and then it falls here like this, it comes out. Okay, so at 7 o'clock in the morning, the shadow is length of the shadow of a 15. So at 7 o'clock in the morning is early in the morning, it flows in this direction. Okay, let me consider this as, okay, what is the height of the pole? This is 15 meters. At 7 o'clock in the morning is what they said. So I am assuming this side, because in the morning the shadows are a bit longer than the height. So this is 15 root 3. Then what is the angle of elevation of sun rays with the ground? Angle of elevation is always with the ground at the time. Okay, so the shadow, length of the shadow is given, and the clue for the shadow at what side this falls is given as 7 o'clock. Alright, so here we know at opposite side and adjacent side. Alright, solution given A, B, C. We need to figure out theta. Okay, as we have known opposite side and adjacent side, can I write it as tan theta is equal to BC by AB. BC is 15, AB is 15 root 3. 15 gets cancelled. Tan theta is equal to 1 by root 3, which implies theta. For which value of theta? Tan is 1 by root 3, 30 degrees, and hence the angle of elevation is 30 degrees. Alright, so what have we done? Given the length of the shadow is, height of the pole is 15 meters, length of the shadow is 15 root 3, we got the opposite side and adjacent side. In order to figure out theta, we identified a trigonometric ratio with both these sides, which is tan. and from there we have figured out the theta, which is nothing but the angle of elevation. That's about problem number 4. Let's jump into problem number 5. So let's look at problem number 5. Okay, you want to erect, what is erecting a pole? Make it stand. Okay, you want to erect a pole of height 10 meters with the support of 3 ropes. So if you have an idea of tents or shaminas, how they are going to be, so for a pole, even for a pole to stand, what he is saying is, this is stood with the help of 3 ropes. So one rope is, let us assume one rope is here, one rope is here. The other rope should be on the back side. Okay, this rope is on the back side. Okay, each rope has to make an angle of 30 degrees with the pole. This makes an angle of 30 degrees, this makes an angle of 30 degrees, and this is going to make an angle of 30 degrees. Okay, I drew this. This is supposed to be on the back side, like this. Okay, the third rope will be like this. Okay, so what should be the length of the rope? Here it is tied with the help of 3 ropes. Okay, let me ask you. So he says whole height is 10 meters. This height is 10 meters. Let me put it correctly. 10 meters. Okay, let me name this as A, B, C, D and E. Now the rope is making an angle 30 degrees with the pole, and he is asking us the length of the rope. How many ropes do we have? 3 ropes of same length, right? With the support of 3 ropes. So if I find the length of one rope, then it is nothing but the total length of the rope is 3 times the length of the rope. Alright, if I assume the length of the rope is x, here it is also x, and this is going to be x. What is the total length of the rope? Not only one rope, right? He is asking length of the rope, which is nothing but 3 ropes length, which is 3 times x. Alright, so let's get started. Now, solution. Each rope has to make an angle of 30 degrees. Here we have 30 degrees. Here we have a right angle. Here. So if you look at this, we have adjacent and angle. What do we have with respect to adjacent side? We know cos 30 is equal to, what is cos 30? 10 by x. 10 by AE. Okay, 10 by AE. Cos 30 is root 3 by 2 is equal to 10 by AE. AE. Siva, so for the fourth problem, here we know that the length of the, we assume the length of rope to be x and height of the pole is 10. So since we know the adjacent side and the angle, I am writing it as, we know cos 30 is equal to adjacent BE by hypotenuse AE. What is BE? 10 by AE. This is cos 30 according to our trigonometry table, root 3 by 2. AE is equal to 10 into 2 by root 3, which is nothing but 20 root 3. What is KE we thought? That is the length of the rope. But they are asking what should be the length of the rope. What is the length of the rope? He said it is tied with the support of 3 ropes. Okay? With the support of 3 ropes. 3 ropes is nothing but 3 times AE is equal to 3 into 20 by root 3. That is equal to root 3 into root 3 into 20 by root 3. Okay, what does this become? 20 root 3. What is the value of root 3? If you still want to simplify, root 3 value is 1.732. If you multiply 3AE, the length of the rope, length of the rope is equal to 3AE is equal to 20 root 3, which is when multiplied with the value of 1.732, you get 34.6 change. Okay, when you do this multiplication part, if you are solving till this also fine. If you still want to do this, just do this multiplication part. This is going to be a value of 34.6 change. Okay, that is about problem number 5. So we have discussed these till problem number 5. So for you, since you are listening this for the first time, it will take little bit of time. So now that you have listened to these problems, I recommend you to just go through the questions and try drawing the diagrams by yourself. Now you understood, even if you haven't gone through the examples, now you have understood how am I drawing the diagrams, right? So till 5th problem, I am stopping this video for 5 problems itself. Now whatever you have watched, just keep it aside and take your textbook and try drawing the diagrams. So reading the problem thoroughly and try understanding the problem and try drawing it. So if you get it the same way which I have taught, or you are trying in a different direction which is also leading to the result, or you think why did you do this way, why can't we do this way, that all is also fine. If you figure out another way of solving the same problem, that is also fine. If you feel anything you are missing or if you are not understanding it, just ping me in the comment section saying this is what we need an explanation for, or this is what we would like to listen one more time, like that. Okay, so till 5th problem we are stopping here. I recommend you to solve by yourself. If you feel that you are familiar with first 5 problems, try solving the next 5 problems as well by yourself. If you are able to get it, well and good. If you are not, I am going to teach them in the next session so that you could go through them and understand where have you gone wrong. Okay, so if you feel that the content is worth enough, please do like, share and subscribe to Anandalakshmi Academy. Thank you.